arithmetic progression and geometric progression. Nth term of an arithmetic progression, that is AP. Nth term of an arithmetic progression, sum of first n terms of an AP. Nth term of an arithmetic progression. This is an AP minus 1.0, minus 1.5, minus 2.0, minus 2.5 and so on. Now if we start to count its term, we can count only up to fourth term. Suppose we have to find out its eighth term. How can we find out? For that, we need a help of first two successive terms. From these terms, we get A is equal to minus 1.0 and D is equal to minus 0.5. What is AP's second term? AP's second term is minus 1.5. And how did we get this? Minus 1.0 plus into bracket minus 0.5. Now as we know, we denote first term as A1 is equal to A, second term as A2. Therefore, A2 is equal to A plus D. We can write it as A2 is equal to A plus 1 into D. Now observe here that the multiplier of D is less than 1 of the term number of the term we have to find out. This is also can be written as A2 is equal to A plus into bracket 2 minus 1 D. What is AP's third term? AP's third term is minus 2.0. And how did we get this? Minus 1.0 plus into bracket minus 0.5 plus into bracket minus 0.5. Now as we know, we denote first term as A and third term as A3. Therefore, A3 is equal to A plus into bracket D plus D. We can write it as A3 is equal to A plus 2D. Here too, the multiplier of D, that is 2, is less than 1 of the term number of the term we have to find out. Therefore, A3 can be written as A3 is equal to A plus into bracket 3 minus 1 D. In this way, when we reach up to 8th term, that is A8 will be A plus into bracket 8 minus 1 D. Therefore, 8th term of this AP will be minus 1.0 plus into bracket 8 minus 1 into bracket minus 0.5 is equal to minus 4.5. As we find 8th term by A8 is equal to A plus into bracket 8 minus 1 D, to find nth term, we need to just replace 8 by n and we get An is equal to A plus into bracket n minus 1 D. Therefore, the nth term of An of the AP with first term A and common difference D can be easily found out by the formula An is equal to A plus into bracket n minus 1 D, where n is equal to 1, 2, 3, 4 and so on. AN is also called the general term of the AP. If there are M terms in the AP, then AM represents the last term, which is sometimes also denoted by L. Sum of first n terms of an AP.
Guys,
A mathematician, a problem was given to him to solve when he was just 10 years old. He was asked to find the sum of the positive integers from 1 to 100. He immediately replied that the sum is 5050. Can you guess how did he do? He wrote S is equal to 1 plus 2 plus 3 plus so on plus 99 plus 100, and then reversed the numbers to write S is equal to 100 plus 99 plus 98 and so on plus 3 plus 2 plus 1. Adding these two, he got 2S is equal to 100 plus 1 plus 99 plus 2 plus and so on plus 3 plus 98 plus 2 plus 99 plus 1 plus 100. As a result, he got 100 plus 1, 101, 99 plus 2 is equal to 101 up to 100 times. So, S is equal to 100 into 101 divided by 2 is equal to 5050. That is, the sum of positive integers from 1 to 100 is equal to 5050. We will now use the same technique to find the sum of the first n terms of an AP. A plus D, A plus 2D and so on. The n term of this AP will be A plus into bracket n minus 1 D. Let S denote the sum of the first n terms of the AP. We have S is equal to A plus into bracket A plus D plus A plus 2D plus and so on plus A plus into bracket n minus 1 D. We consider it as first sum. Rewriting the terms in reverse order, we have S is equal to A plus n minus 1 D plus A plus n minus 2 D and so on plus into bracket A plus D plus A. We consider it as second sum on adding first and 2 term-wise. We get S is equal to n upon 2 into bracket 2A plus into bracket n minus 1 D as there are n terms. So, the sum of the first n terms of an AP is given by S is equal to n upon 2 into bracket 2A plus into bracket n minus 1 D. We can also write S is equal to n upon 2 into bracket A plus into bracket n minus 1 D. As S is equal to n upon 2 into bracket A plus AN, since AN is equal to A plus into bracket n minus 1 D. Now, if there are only n terms in an AP, then AN will be L. The last term, therefore, S is equal to n upon 2 into bracket A plus L. We can use Sn in place of S to denote the sum of first n terms of the AP. If we know any three of S, A, D and N, we can find the fourth term. The nth term of an AP is the difference of the sum to first n term and the sum to first n minus 1 terms of an AP, that is, AN is equal to SN minus SN minus 1. Summary. In an AP with first term A and common difference D, the nth term or the general term is given by AN is equal to A plus into bracket N minus 1 D. The sum of the first n terms of an AP is given by S is equal to N upon 2 into bracket 2A plus into bracket N minus 1 D. If L is the last term of the finite AP, say the nth term, then the sum of all terms of the AP is given by S is equal to N upon 2 into bracket A plus L. So that is all about this topic. Let us summarize what we have learned in this learning object. So that is all about this lesson. Learning is fun.